Hi there. In this video, we're gonna confirm HelloWorld VSTL program on real hardware and actual FPGA. The objective of this lessons are, we're going to create HelloWorld Lattice Diamond project for MachXO3 9400 FPGA development board. The source is available on the GitHub link. This link will be posted in the description of the YouTube video as well. We're gonna perform port IO mapping, and then we're gonna synthesize the design, and using Lattice synthesis engine, we're gonna perform map trace, place and route, IO timing analysis, and then generate a JEDEC file, and then we're gonna download this JEDEC file for the HelloWorld design on MachXO3 9400 FPGA development board. Alright, to get a user guide for the board that I have, you can go to pro.tips website and then go to Learn VSTL online course. And if you go to course resources, you're gonna see a link to development board that I'm using, which is MachXO3 9400 development board. You can open this link, and you can also see the GitHub link to the this course as well, which is the Learn VSTL on our GitHub website page. So for this HelloWorld .vst is located in section 2, lecture 1. HelloWorld.vst is here. This is the file that we'll be compiling and loading on our FPGA. So if you click on this link, a MachXO 9400 development board, it will take you to this website for Lattice Diamond. If you click on documentation and you download the user guide, you can open that and then look at the board that I have. So the main first purpose is we can look at how the board looks like, right? The board has pictures here. This file has pictures of the board. Top view. This is the front of the board. There are various LEDs on this board that we can control with the FPGA. This is the FPGA. If you zoom in on it, it's LCMX03LF 9400C. And C6BG484C is the chip. There are several LEDs here that we can control using the pins that are listed here as well of the FPGA. D1 will be controlling D1 LED. So this is for our HelloWorld program. We have a single output. This output is LED out, and for LED out we'll use D1 LED. All right, so it makes sense to use the first one, although it's not the first one in this list here, but we'll be using D1 for turning on this on off this LED that we want to basically toggle from the clock input. So clock, where is the clock, right? So the clock itself, I'm using an external clock which will be coming into the FPGA. So for clock, we're gonna have to find an input pin that can be used. So for this external clock input that I have almost 1 megahertz clock coming into this board from an external like a generator board that I have. I don't want to talk too much about that, but that's just a separate project that I made to generate 1 megahertz clock to this board. So if we go on to down below, we can actually click on the block diagram bookmark here as well. You start seeing various IOs that are available on the FPGA on different banks. So the one that we care about is PCLKT. those are the primary clock pins, right? So we want to look to see which one is available. B12, A12 are not available. So is 12 megahertz here is not available as well. So this one is not wired on this board. This one here as well is, is not the best choice. This one is not wired as well. So U2 here is a good pick. The reason is that this is a direct pin from Raspberry Pi. So there's a header on the back of the board. So U2 will be 1, 2. So if I search for this tag, I will check to see right here. 1, 2, 3, fourth pin on the first side. So this is JP3. JP3 is actually on the back of the board. JP3. This is JP3 here, right? So it's actually fourth pin here, right? So I'll be connecting on that for the clock input. So we know that we're going to be using U2, which is available on JP3 on the fourth pin on the right side here, okay, for the clock input. So last remaining is the reset input pin. For that, we're going to select the first dip switch, H5. All right, this is an easy pick because dip switch is what we kind of need. So we'll be normally so when the reset will be 1 whenever this is not pressed. If it's pushed downward, the dip switch will be going to 0 and then we'll be blinking the LED. All right, so we have the 3 IOs that we want to pick for our design. All right, so we're gonna go ahead and create the project now using Lattice Diamond. To create FPGA Lattice Diamond MachXO3 9400 development kits board, we're gonna go through this creation of Lattice Diamond project. We're gonna name this project HelloWorld and pick the location for it. I'm gonna keep it in my documents and diamond and in here in this folder. I'm gonna make sure that this folder has nothing else in it. It's true. And for the source, I want to add HelloWorld file that we created in here. You don't include the test bench file, only the helloworld.vht. I want to copy the source in here, so leave that checked off. 9400C. And the board that this is 9400C 484C. And I do have external SC number 1. So for this, we're going to use Lattice LSC for synthesis tool. And we don't need platform designer file for our exercise. So uncheck this settings off. Nothing should be checked off in the beginning. And you just click Lattice synthesize engine to have the project synthesized. If you look at the file list, you'll see that your inputs you should only have helloworld.vht in here so far, and an LPF file as well. But we're gonna go ahead and change the LPF file by updating the port mapping for it. So for our clock, we said we wanna use U2 pin. If you go back, we could look at that again. Yes, it's U2. And for reset input, we said we're gonna use H5, which is the dip switch number 1. And for our LED out, we're gonna use D1. And once we do that, now you are sorry, didn't type here right, D1. And next thing you want to do here is you hit save, you go to timing preferences, go to frequency, and port for clock you have 1 megahertz input, right? So that's all you do in there, and hit save. Then you can check off in process window, you check off map, trace, place, route, trace, IO timing analysis, and you check off JEDEC file. So that's sufficient for us for this exercise. Next thing you do is you just double click on export files. That should go through the compilation process to synthesize the project and perform various these tasks we checked off here, all of them. The last thing it does is generates the JEDEC file. If you go to errors and warnings, you have none. It's a successful compile. What we're gonna do now is we're gonna go on programmer, and I have FTDI, and I click OK. So it'll go through scanning of so I have the USB wire connected on it. If you I can show you real quick how it looks like. So the USB wire going into the board is up top, the mini USB wire, and at this point what I'm expecting is the project to be successfully loaded on it. So what you do next is you on this programmer file programmer window, you have the device. You want to make sure it's the same as your device that you have, which in my case is 9400C, which looks all good. I'll just hit save here and then click download. It's going to be programming the FPGA right now. It does flash erase program and then verify automatically. For what I have, by default it does that. What I have it set up for. So at this point, my FPGA is programming. If you can see all the lights turned on, that's what happens during the FPGA programming mode. At this point, the operation was successful. And if I look to see, the D1 is now blinking every second. It goes off and then on, off and then on. In the next video, I will do some timing analysis that we'll see further in further lessons.